Spaceprobe flew by Mars to send TV pictures. Next July, by Walter Sullivan, July 15th, 1965. Pasadena, California. Mariner 4 completed its rendezvous with Mars this evening and sailed on into space, carrying, it is hoped, a series of tape-recorded pictures of that mysterious planet. Instruments aboard the spacecraft indicated that Mars had no significant magnetic field and no appreciable radiation belts. Its lack of a magnetic umbrella has a direct bearing on its habitability. Life on Earth is protected by the shield of this planet's magnetism, which diverts incoming radiation from the Sun and exploding stars, radiation that might otherwise be lethal. Mariner 4 went through its complex preparatory procedures today without any apparent mishap. However, during the picture-taking sequence, there were hints, in radio data from the spacecraft, that the control system of its tape recorder was not functioning properly. The task of the recorder is to store the pictures until they can be slowly transmitted to Earth. It appears possible that the mechanism designed to stop the recorder between pairs of pictures malfunctioned at some point in the sequence, allowing the recorder to run unchecked and erasing some of the pictures. At a press conference late tonight, officials said signals were received announcing that the tape recorder started and stopped properly. They also said it was evident that the television camera was working since it responded to the sudden drop in light input as the spacecraft sailed from the day to the night side of the planet. Dr. William H. Pickering, director of the Jet Propulsion Laboratory, which operates the Mariner project for the National Aeronautics and Space Administration, expressed optimism, as did his associates. He pointed out that every explanation that we have attempted to give says we have some pictures. However, he added that the nature of the difficulty and the number of pictures recorded may not become known until the end of the full playback period of the next 10 days. The first transmission of a picture is to start at 8:41 a.m. tomorrow, or a few minutes earlier. It will take 8.5 hours to send the first picture. During the initial part of that time, a dish-like antenna at Johannesburg, South Africa, 85 feet in diameter, will receive the signals. Then the Earth's spin will carry Johannesburg out of line, and a similar antenna at Goldstone, California, will take up the watch. A newly operational antenna of the World Girdling System at Madrid should be able to receive the entire picture. The pictures, if received, will be the first ever obtained in the vicinity of another planet. Officials of the Jet Propulsion Laboratory have sought assiduously to temper the excitement that has built up here. At a press conference yesterday, Pickering held up some fuzzy photographs of patches of the moon and said this was the best to be expected from the Mariner television system. Yet, the pictures should be better than any ever obtained from Earth if the system operates properly. They should, for example, indicate whether or not Mars is webbed with straight-line features resembling the controversial canals. The reality of the latter has been challenged, but they persuaded some 19th-century astronomers that Mars was the home of a super-civilization. After the first few lines of the image have been received at Johannesburg, tomorrow morning it may be possible to tell whether or not the system has performed properly. The enthusiasm of those at the Jet Propulsion Laboratory over the Mariner 4 performance, ever since its launching last November, 28 has been matched by their fear lest something go wrong during the critical moments of flyby. Since the picture-taking sequence took only 25 minutes, it was impossible to correct any malfunctions once it had begun. This was because of the 12-minute travel time for radio signals from the spacecraft to Earth and vice versa. If, for example, a signal had been sent by the vehicle indicating that the tape recorder had not started and hence was not recording pictures, this news would have taken 12 minutes to reach Earth. Any corrective signal would have taken another 12 minutes to get back to the vehicle, and virtually the entire flyby would be over. This, and fears that the onboard command systems might not function properly, led to a number of revisions in the flight plan. These sought to control as much as possible of the flyby sequence from Earth. The project leaders also wanted to get as much done well in advance as possible, allowing themselves plenty of time for corrective action and time, literally, for the dust to settle. Apparently, early in the flight, dust was released and drifted in front of the electric eye that keeps one side of the vehicle oriented toward the star canopus. For days, the vehicle spun on its axis, chasing dust particles. An adjustment in the eye, controlled by radio from Earth, brought this to a halt, but there was fear of a recurrence if more dust was dislodged in preparatory maneuvers. Today's most delicate operation was to aim the television camera by command from Earth. It was decided to calculate on Earth the proper angle for the camera, set the platform rocking back and forth, and then command it to halt at just the right second to achieve the correct aim. At 10:28 a.m. today, the order was sent from Johannesburg to begin scanning, and 24 minutes later word came back from the spacecraft that this had been carried out. The scan was slow, with 6 minutes required to complete each semicircular swing. For more than 2 hours, the specialists here studied the signals from Mariner. They could tell every time the rocking platform reversed direction and decided that, if Johannesburg sent the command to halt scanning at precisely 18 seconds past 1:10 p.m., the signal, when it arrived 12 minutes later, would stop the scan when the camera was aimed just right. This was done, and the anxious technicians waited for the answering signal from 134 million miles away. When it came, it told them the platform had stopped rocking and the camera was aimed within 0.7 degrees of the intended direction. Again, they decided to exert control from the Earth for the action programmed for control by the vehicle's own sensors. This time it was the initiation of the flyby scientific transmissions, designed to assess whether or not Mars has a magnetic field, radiation belts, a possible envelope of cosmic dust, and so forth. During most of the 228 days of interplanetary flight, 2/3 of Mariner 4's radio transmission time was allocated to scientific data, and a third to engineering data. However, when the camera's wide-angle sensor detected Mars a half-hour before the start of the camera run, this was supposed to initiate full-time transmission of scientific data for the flyby. It was decided, however, to start these transmissions by command from Goldstone, and this was successfully done shortly after 6 p.m. At 9:03 p.m., after making its 25-minute picture run, Mariner 4 came within 6,117 miles of Mars, achieving 11,471 miles an hour, its maximum velocity relative to Mars. At 10:19 p.m., it slipped behind Mars, and 52 minutes later, it reappeared on the other side. The playback of the pictures is being delayed until the receipt of all scientific data from the vicinity of Mars and a thorough check of the vehicle's engineering condition. It has on board enough of the compressed nitrogen gas used to operate its tiny aiming rockets that keep the vehicle pointed toward the sun, so that its solar panels can generate electric power for at least 3.5 years as it sails majestically in a slow orbit around the sun. In September 1967, it should come within about 25 million miles of the Earth, and there is at least a long chance that contact with the vehicle could be resumed at that time. On the present stage of its flight, it is hoped contact will be maintained for at least another month or so,